Good morning students. Today we are discussing about the array order, reversal, array counting, binary search and linear search. So here we are discussing about the introduction to the arrays. So arrays are the fundamental data structures that it holds the fixed size. So here first we call it as a arrays to the fixed data type to store the size. So here we decided to give the how many bits of data to store a size. So we call it as a for array we give it to the size. So it's efficient access to the elements using an index set. So to understand the operations on arrays is a crucial for algorithm development. So for algorithm development it is a crucial to identify the array. First we call it as an array to give the number of values in a homogeneous. So here we take the number of elements to store in an array. So we give it as a fixed size to the array, and we call it as an array declaration. For example, here we say that the data structure store similar elements, and it gives you the fixed number of element to store in an array. The length of array is assigned for created after creation. Its length is fixed. So after we are creating the array length, it's fixed. So after that we assign to the data to that array. For example, we call it as a length of array is 6. So here is a int a of brackets equal to new int 6. So it will create an array of length 6 and index values. So here it takes the 6 number of index value to store in an array, that is 10, 20, 30, 40, 50, 60 from starts with 0 to 5. So here we count 0 also one of the data storing element. Next, array order reversal. Before class we discussing about the reversing elements. So same that here the array order reversal is the process of reversing the elements in an array. So here we taking to the index, for example 10, 20, 30, 40, 50, 60. Here 0 to 5. So here is the array order bit length is 6. So here we apply in the array order reversal. So it starts with 10. Firstly it starts with 10, ends with 60. So here after applying the array order reversal, it starts with 60 and ends with 10. So this can be done in a place, meaning it doesn't require additional memory for a new array. So it does not require any new array to or a new memory. In that memory only, firstly what are we are calling to the array, in that memory only the reversing data also stored. Reversing an array can be useful in various algorithms and applications. The method of reversing arrays is in common method. Reversing array is to swap elements from both ends. So here we swapping the elements from both the ends is the method of reversing arrays. In that reversing array, this is the different method to the swapping both ends. This continues until the middle of the array is reached. So here it continues, the middle of the array is reached, this swapping method we continue. The time complexity of this operation is 0 of n, where n is the number of elements. So here we declare the n is the number of elements. Original array is 10, 20, 30, 40, 50, 60. So here after we apply in the method of reversing array, that swapping elements both. So here until it this process repeated until it comes from 60, 50, 40, 30, 20, 10, like reversing array. Next, example of a array reversal. It consider an array 1, 2, 3, 4, 5. So for example, we are taking the array 1 to 5 numbers. After applying the reversing method, the array become 5, 4, 3, 2, 1. So here we are observing that the before runs the array order is 9, 7, 1, 8, 6. So after we applying the reversal array 6, 8, 1, 7, 9. So these are the public static reversal to we use the assume in a class of array. So this information transformation illustrate how elements are swapped from opposite ends. So here opposite ends are how elements are swapped. It observes. Next, array counting. So array counting involves to determine the number of accurate each element in an array. So here we observe that the places should count the 0 to n numbers. So here the array counting is 12. So element is 12, the count is 2. 9, the count is 3, 12, 9, 10, the count is 2, 11, 1. So here from both the ends the data is counted. Here 2, 3. Next from the right of the array element 10 is 2, 11 is 1. Next, the array counting involves to determine the number each element in an array. This is particularly useful in a frequency analysis and statistical computation. In this computation, the complexity can vary based on the method we are used in the array element count. So counting elements efficiently. So what will do that? Efficiently counting elements. For example, hash table, keys John Smith, Lisa Smith, Sundar, and sum of three names are there. We are doing the in middle hash function. Here we have the buckets. So that data is stored in a buckets. So here 3 data. We are giving the matchings to that data. So that approaches count element, it used to hash table or directory to find out that particular actual data where it is stored. This allows for 0 of n times complexity when continuous unique elements. Each element processed once, allowing for efficient counting. So here efficient counting, for that it allows processor for efficient counting, it allows each processor only once. So each process only one time only it can exist for the efficient counting. We cannot perform at a time or twice because it gives you the clumsiness to the crossing. Like we are observing an image, here we observe that it's crossing John Smith and Lisa Smith. Like that, the efficiency of counting is some misplacing. Next, example of array counting. For the array, there is a 3, 1, 2, 3, 2. It counts would be 3, 2, 1, 1, 2, 2. So this example showcases how each element frequency is recorded. So each element of the recorder it stores. Next, counting can be easily visualized using bar graphs and histograms. So we are counting can be easily visualized when compared to the orally or number wise. We are telling that when compared to that visualized data is more impact to that everyone to identify easy. So that's why the visualizing using bars, graphs and histograms we identify the array counting. Next, introduction to the search algorithm. See, here we discussing two algorithms, that is a search algorithm. In search algorithm, fundamental operations in data structures and algorithms. So data structures and algorithms, we are fundamentally what are the operations apply in a search algorithm. It involves finding specific elements within array or data set. So this operation is performed within the array or data set that we are given to the array number of sets and number of element to store and data set. In two primary algorithm searchings are linear search and a binary search. In search algorithm, two primary algorithms are we are frequently using, that is the linear search and binary search. In this algorithm, we observe here the characteristics of algorithm. So for characteristics of algorithm, firstly we have well-defined inputs. From that algorithm, we give to the well-defined inputs and we are expecting well-defined outputs. In this inputs and outputs, we perform the four operations clearly, that is clear and maintain the good database and language independent. Give the language that are selecting language to give perfect instructions and libraries that are called as a libraries, and feasibility and fitness. So feasibility also must for the search any algorithm to build for reusing and re-embarrassing to that the algorithms. Next, linear search. Linear search checks the each element in the array sequentially. So here we observe that the linear search element in the array sequential. It is straightforward approach but can be insufficient for large data sets. It is a straightforward. So firstly here we giving the sum of the elements numbers. So here I want to find out the kth value, that is k equal to 41. So in this array I want to find out the search the array value k equal to 41. So it is a straightforward approach but can be insufficient to large database. The time complexity is 0 of n, where n is the number of element in the array. So here one by one I will search in the array for multiple times until k equal to 41. So firstly you observe that k not equal to 40, k equal to 30, k not equal to 11, k not equal to 57. So last one it gives the k equal to 41. So here the linear search, so here it stops the process of the linear search. Next, example of a linear search. So here we observe that the example of linear search is in array 5381. It 3 involves the checking element. So here I check the element 5 and then 3. Find the element on the second check. So this method guarantee finding the element if it exists in an array. So here first we find out the element of 12 in the given array of 65, 20, 10, 55, 32, 12, 50, 99. So step 1, step 2, for in these multiple times I will give search to the linear search for until the value find out the 12. So both the matching, so we stop comparing and displaying elements around the index in this array using the linear search. Next, binary search. In binary search is a more efficient algorithm but requires the sorted array. But here we have the sorted array, but no clumsiness in that array for using the binary search. It works repeatedly, dividing the search interval in half. The time complexity of 0 of log n, making it significantly faster than linear search. So it gives the binary search works faster than the linear search. How to binary search works? The algorithm compares the target value, the middle element of the array. If the target is less than the middle element, the search continues in the left half. So here we compare to the binary search, search 78. So it's right side of the first element, left side of the first element is 21. So look at for the 78 in the right half. So here we search in the target is greater, the search continues in the right half. The target is less than the middle element, the search continues in the left half. Next, example of a binary search. It gives a sorted array 1, 2, 3, 4, 5 and searching for the element 4. The middle is 3. Since 4 is greater than 3, the search continues the right half of the element. So it is easy to identify where the element is there. For firstly we compare the middle of the element, that we are searching the element is greater than or less than. For the middle of the element we compare, then we start search from right side of the element or left side of the middle of the element, so where the search is successfully find the target easily and in less time. So when comparison of search algorithms, linear search is simple and work on unsorted arrays. Linear search is unsorted arrays, while binary search is faster for sorted arrays. So linear search can search the elements in a unsorted arrays and sorted arrays, but the binary search is faster for only sorted arrays. Binary search dramatically reduces the number of comparisons needed. So binary search reduces the number of comparisons needed. So only the middle of the element compares the what we have searched the element. Choosing the right search algorithm depend on the data's characteristics and requirements. So here we conclusion is understanding array operations and search algorithms is essential for efficient programming. Each technique serves different purposes and scenarios in data handling. Mastery of these concepts enhance problem solving skills in computer science. This presentation covers the requested topics, providing the consecutive overview and example for clarity. Thank you.